so let's look at some practice proofs here and see what we can come up with. So the first thing is that the proofs are two-column proofs. So on the left is the statement, on the right is the reason. Did you guys get to that in class today at
No,
all?
probably
Okay.
get to that tomorrow.
All right. So the thing on the left, all the stuff you see on the left is like stuff you're used to writing, and the stuff on the right is new. It's like you have to justify each step. You have to say, oh, this is why it's true. Now, the very first statement is always, always, always the given. Always, always, always the given. That's something to remember. The very last statement is always the proof statement. Okay, so those are important things to remember. Now, what you're trying to decide is what did you do to go from statement one to statement two? What is the like difference between them? And what sometimes you have to do is come off to the side and actually solve it. You have to say, all right, well, if I add 18 to both sides, what does that do? Well, it becomes 5x equals 3x plus 20. So the step here is the addition property of equality. So it's like what did you do to go from one to two?
Oh,
You have to supply a reason. Is that okay? Or not?
yeah.
Okay. So the next thing here is well, what are you going to do to solve this equation? What do you see as the next thing to do?
Subtract. Wait, no. Add 3x to both sides, or subtract 3x from both sides.
Subtract 3x from both sides. And then does that match? Does that match like
Yeah.
the direct? Yeah. So this is 2x equals 20. That's the subtraction property. Then does this match here? Are you dividing to get to this last step?
Yeah.
Okay, great. Any questions on that? Thoughts on that?
No.
All right. All right. So let's look at another one here. Most students like these because they're familiar to them. They already know how to solve the equations. All right, so for the second example here, again, that given always, always, always goes in the first position. It's always, always given, okay? No exceptions.
Oh, you want me to like
Well,
solve
I
it?
want you to think about what
Um,
like it says multiplication property. What could you be multiplying both sides by in this
3.
first line? Yeah. So tell me tell me what that becomes when you multiply both sides by 3.
2x minus 6 equals 8 times 3 is 20, 16, 24.
24. Good. Okay, then it says a different property. Looks like they're adding 6 to both sides. That's fine. How are they going from line 3 to line 4? What is the step there to do
Addition.
that? I'm sorry?
Addition
So
property.
no, so no. So to go from 2 to 3 is the addition property.
Oh, okay.
How about from 3 to 4?
Oh, divide.
Division property. Okay. All right. Um, any questions, thoughts on that before we continue here?
No.
I think you're getting the idea. There are a number of other properties though that maybe you like, you know how to do, but don't know the name of. So that comes into play on this this next one here. So the first statement is, and the reason is always given. I want you to look and tell me what's happening to go from step one to step two.
They solve the parentheses. Or they
Okay, so do you remember?
distribute.
There you go. That's the right word. So they're very particular about the word distributive property. Okay, now to go from 2 to 3, they're telling you combine like terms. What do they mean by like terms in this?
Um, Combine the x values and the non-x values.
That's right. So what does the left side become when you combine the x values and non-x values?
17, and the right side is, yeah.
Okay. So subtraction property. Now, what's not clear is whether they're subtracting the numbers or the variables. You get to kind of decide. Um,
27 plus 28 is 40, 55. So 17 plus 55 equals 12x. That's right.
yeah, I mean, are you going to subtract the x or the numbers? I'm sorry, I didn't quite
Oh,
follow.
it's the numbers first.
Yeah, so that's fine. So it becomes 17x equals 12x minus 55. And then when you subtract the 12x, it becomes 5x equals minus 55. What are you doing to go from step 5 to step 6?
Divide.
Vision property. Very good. All right. So what I'd like you to do now is try one from start to finish. They're not going to give you any of the it's not going to be filled in. So I'm going to just ask you to try it on your own. What I don't know is whether you actually have to fill in all the blanks here. Meaning there's 1, 2, 3, there's six steps. But go ahead and work this out as best you can on your own there and let me know what you come up with.
First one is distributive.
Yeah, go ahead and work it out as much as you can. Work it out on the left and then put down, one word on the right or make a mental note of what it is.
Oh, wait. Okay, so the first one is distributive, and it
Okay,
becomes
tell me. Yeah, that's fine. And then tell me what to write on the left.
48 equals 10x minus 35 plus 3.
Okay, good.
The next one is addition, or yeah, addition, and then it's 48 plus 32. Oh wait. Oh wait, so you want, okay, wait, no, sorry, 80.
So
Well,
you're doing too many
wait.
steps. You're doing too many steps. So the next thing would be to combine like terms or simplify. Sometimes just
Uh,
simplify. it would be 48 equals 10x minus 32. Like that.
Yeah, and then the next one would be subtract.
Then
Oh,
it would, yeah,
addition.
add.
And then do,
This.
and then it would be 80 equals 10x.
Okay.
And then the next one is divide.
Okay. So what does it become? X equals.
8.
Okay. Good. Let me have you try another one here. So go ahead and work this out as much as you can, please.
X plus. All right. So you multiply by 8 on both sides.
Yes, go ahead and work out as much as you can. I agree with that first step.
No, I finished. X equals 11.
Okay, okay, good. What's your first statement?
You multiply by 8.
So the first one, maybe I didn't do this on the first one. The first one is always the given. So they're actually, this all should have been shifted down.
Oh,
But that's me. I should have said that. All right. Give me the next line after you multiply.
after that um you get X plus 5 equals 16.
Okay, good.
And
And
then
then
you subtract,
subtract.
and then you get X equals 11.
Good. Okay. Let me see if there's anything more difficult than this that you might see. Otherwise, you're ready to move on to more challenging proofs. I don't expect you to read this now, but I'll put this in the notes in case you want to look at it later. There are a number of properties that you might need to know. I know this looks overwhelming. You actually know most of these, but I'm just throwing that up there in case you you want to look at it later. Blah blah. Let's see here. All right, here is. Yeah, these are all about the same. Okay, so the next type of proofs that you do are like with midpoints and angles. So I'll put some of those up in front of you. Want the solution? I want the blank. No, no, no. Right. All right, so give me a moment here. I've got another student that did this previously. I'm gonna go just quickly find some of her homework that we can look at to make this go better. Okay, so I apologize for this is a picture, it's a snip of a picture of a screen. It's not the best. It's gonna be okay. So this is the next types of proofs that they give you. This is where you're like, okay, now I'm in geometry and I'm doing a geometry proof. So they always have to give you something. In this case, they tell you that AB is congruent to CD. And then they also tell you that BC is congruent to DE. And you're supposed to prove then that AC, which I'll show here in in red, A to C is congruent to C to E. Now, just like visually, does that look reasonable to you? That if like the part is equal to a part and another part is equal to another
Yeah.
part, like they should be somewhat reasonable. Okay. All right. So the reason for the first statement is always given. Always. But this time they give you two givens. So the second one is also given. All
Okay.
right, now let's look at the third one. The third statement says AC, which is this right here, equals AB plus BC. In your own kind of words, what does that say? What does that mean to you?
AC equals AB. They're all congruent? Wait, no. Oh, wait,
Now,
no.
AC, the whole thing, is equal to AB plus BC. Like, what do you take away from that?
Oh, wait. The whole thing. Oh, so AB is one part and BC is one part.
And then AC is
The whole, yeah.
the whole. Can you kind of say something to that in your own words? Like, what are we trying to say here?
Sum total.
Yes, you used a good word there. So it's called the segment addition postulate, something like that. Basically, you're saying this part plus this other part equals the whole thing. Segment sum, something like that. And the same thing is for this other one. CE is CD plus DE. All right, now the next line here is kind of confusing. It's like, where did this come from? So sometimes you have to figure out like what's the same and what's different between lines. And um, the what you sort of have to be shown this. So CE is here, okay, and it's AB plus BC. There's AB plus AC. What do we know about AC and CE? What was given earlier in the problem?
Um,
Well, I guess they don't do that here. Never mind. Sorry, I guess I was going somewhere they're not doing that. We know that CE is, why are they doing that? AB plus,
oh, and they're saying like AB and BC, which is basically AC, is congruent to CE.
yeah, but there's a problem. This is actually not, I remember this now. There's an issue with this. So what we're trying to say is that why did they do this? Okay. You have to, there's two ways you do proofs. And I'll just make this note here. It's either like it from the previous line or lines. So like one line leads to the next. That's one possibility. Or it could be a couple of lines that lead to it. Sometimes it's completely independent, meaning it like has nothing to do with the previous lines. Okay. I believe this is an error. Because no, I'm sorry. I'm just highlighting the wrong things. So let me do this. AB is the same as CD. So instead of CD, they're putting in AB. That's where it comes from. And DE is really BC. That's where that comes from. So they're substituting or replacing. And then they're saying, okay, well, since CE is equal to AB plus BC, well, that's the same as AC. These are the same. Like this, they're saying that this whole thing is this and this are the same. which leads to this line right here, which is the transitive property, which it's okay that you don't have any idea what I'm talking about because how would you know this until you've seen it one or two times? And then the last line, you might wonder what's different between the last two lines there. What is the only difference or differences you see between those
There's
last
a
two
squiggly
lines?
line and there's a line over the top of them.
Yeah, so there's this like weird thing in geometry where you have to say that congruent segments have the same measure. And you just have to do it. You do the same thing for angles as well. All right, we are out of time for today.